Today we're going to be doing 6-4, which is nth roots. And you already know some stuff about roots because you know about square roots, and this is kind of more on that. And I've talked about it a little bit before, so that there's other roots out there like cube roots and other things. So we're going to start with the basics. So just think about this for me first off. Finding the square root of a number and squaring a number are inverse operations. Okay, that's really important to know. Those are what we call inverse operations. Squaring, square root. We've known that for a long time. So, going off that idea then, the inverse operation of raising a number to the nth power is finding the nth root of that number then. So I'll write that down here. The inverse operation of raising a number to the nth power, oh, that looks kind of crazy, let's fix it, the nth power is finding the nth root. Okay, so think more about what this means. So nth power, any power. So if I've got the fourth power, then I can undo that by taking the fourth root. If I have the third power, I can take third root or cubing it, cube root, we'll usually say it like that. Fifth power, then I can take the fifth root. 100th power, something to the 100th power, I could take the 100th root to undo it. So let's do some examples to make this make a little bit more sense. If we have something like x to the third equals 64, we know that's true if we have what for x? Well, 4. I hope you're thinking 4 to the third is what gets me 64. So since I know this statement is true here, 4 to the third equals 64, think about in reverse. So if I was asking you, what's the cube root of 64? I'm asking you what times itself, 3 times, is giving me 64. And so the answer to that is 4. So on this one we figured out, hey, x is 4, because we know this statement is true. Over here we're saying cube root of 64 then is 4. These things go together here. Okay, so let's think about another example. 5x to the fourth equals 625. Eventually, with some guess and check, I hope that you can tell me that 5 to the fourth is what gives you 625. But a different way to do that, we're basically saying, okay, so if we wanted to solve this problem, easier way would be if we do fourth root of 625, because a fourth root will undo something to the fourth power. Those are inverse operations. And the fourth root of 625 will be 5. Okay, so we're saying, hey, these are the examples over here, here's the answers. In other words, 4 times 4 times 4 equals 64. 5 times 5 times 5 times 5 equals 625. Like, that's how we're getting to an answer here. So one more, and I'm just going to write it solely in one direction. So what is the fifth root of 32? Because that's more what we're going to be looking at and seeing. And so in my head I'm deciding what times itself 5 times gives me 32. In other words, what to the fifth is 32. And hopefully you can come up with somewhat quickly that 2 is the number. Because if I do 2 times 2 times 2 times 2 times 2, in other words, 2 to the fifth, that does give me 32 as an answer. Okay, so we're just undoing all of our powers, our exponents, by taking roots. And like I said, there's all the roots you can ever think of. So a general case for this would be saying if I have if I have a to the n power and that equals b, then I'll always know that the nth root of b is equal to a. And so again, you kind of heard some of the things I said, nth root, just like I said, fourth root, cube root, fifth root. That's how you say those things, just like a square root. A few kind of reminders, if you've forgotten. There's some things in here that have names. This thing right here, the symbol, is called a radical sign. Or a lot of times we just use the word radical. But it's important to know, okay, that's what we're talking about. If we say under the radical, we're saying underneath that. This n value right here is something called the index. We've been used to the index always being 2, and we never really have 2 written there, but it's known that that must be a 2. It's square root usually. But now we have different indices or indexes. 3, so then we know we have a cube root. 4, so then we have fourth root. 5, so then we have fifth root. So that index changes things. And the thing underneath the radical is called the radicand. Probably haven't seen that word a ton. Not too big a deal, but it's definitely, you know, somewhat important. So, okay, let's do some simplifying of like more complex ideas, I guess. We'll start with still kind of some basics, but we're throwing in variables here too is the big thing. So directions for everything today are just going to be simplify. So we're just making things as simple as we can. Something to note is that in the past, when we say what's the square root of 64, there's just one answer. The square root of 64 is 8. The square root of 49 is 7. There is only one answer. The only time I'm going to have multiple answers is if I have something like I'm about to write, or if we are solving and a variable is involved. We're not solving anything today, so we shouldn't have like multiple answers, except if we see something like this. So if they put plus or minus in the problem already at the beginning and say plus or minus square root of 16x to the 8th, well then we know we're just going to have plus or minus in our answer. They're saying they want the positive and negative answer with this. So there's not normally pluses or minuses today, it's just one answer. So for something like this, I really do have to think about things separately here. I have to think about the square root of 16 and the square root of x to the 8th. And if I think about them separately, we should know the square root of 16 is 4. And then I have to think about what times itself twice is going to give me x to the 8th. And I hope you can kind of quickly, and I'll write it over here, think about that x to the 4th times x to the 4th. That's what times itself 2 times to give me x to the 8th. So I've got plus or minus 4x to the 4th. There's kind of a little hint in here though too, when you really think about this. I really just divided the exponent of 8 by the index. Remember I told you it's an imaginary index. We don't usually see, like not imaginary, but meaning we don't see that 2 very often. We just assume it, the square root. But it's there. It's definitely there. Zoom in a little bit too. It's kind of small. Let's do another one and see if we kind of get the idea here. So, for example, if I say I want the negative square root, we'll stick with square roots, of q to the 3rd plus 5, all raised to the 4th. What that really means is we've got square root q to the 3rd plus 5 times q to the 3rd plus 5 4 times in there. So how many of those q to the 3rd plus 5s do we have to multiply times itself, because that's what square rooting means, what times itself will get me that. So again, you're really just carrying everything along with it. We've got the negative, we've got the q to the 3rd plus 5. All we're really going to do is remember that index and do 4 divided by 2. 4 divided by 2 is 2. So I know that it must be to the 2nd power. Just like over here, 8 divided by 2 is 4. So it's more dividing. when we're thinking about what we're going to do with our powers on the inside and our index on the outside. Okay, so let's do another one. If we've got fifth root of 243, a to the 10th, b to the 15th. Okay, so now we've got something different. We got fifth root. Fifth root seems kind of weird. But I just have to think about what times itself 5 times will get me that. And if you really have no idea, grab a calculator and start trying stuff. So 1 times 1 times 1, 5 times, that's not going to be helpful. So I can do like 2 to the 5th and see what I get there. 32, I can do 3 to the 5th. And all of a sudden, really quickly, I'm like, okay, 243, so it's 3. The fifth root of 243 is 3. So it just takes some practice and then starting to recognize things. And then it's the same thing with these variables as I was doing up on 1 and 2. I'm literally just dividing. So 10 divided by 5 is 2. 15 divided by 5 is 3. So final answer, 3a squared b to the 3rd. One more just for fun so we don't forget about it. And then we might have something later to talk about with this too. What happens if I have a negative? Okay, let's not forget our negatives. But it makes a difference if I'm talking about an even or odd root. So we've known for a long time that square root of negative 4 is 2i. But what happens when it's something like fifth root, and we'll just use the one from over there, of negative 243? So we know the fifth root of 243 is 3. How about the fifth root of negative 243? If you really think about this, there's no I involved if it's an odd index. Because if I take an odd number of negatives, so a negative times a negative times a negative times a negative, and negative in this case, 2 of them are going to make a positive, 2 of them are going to make a positive, I've got 1 left over, so I'm totally fine. So if I really, really think about this, the answer is just negative 3 instead of positive 3. Because I really can do negative 3 times negative 3 times negative 3 5 times. Let's see if I can squeeze one in over here. And that will be negative 243. I don't need an I don't need anything imaginary. An odd index with a negative works out just fine. So be careful with just assuming every time you see a negative under a square root, it's going to have, or under a root, it's going to have I. If it's under a square root, you're going to have I. If it's under a fourth root, that's a problem too. You might have some imaginary stuff. But it's under a third root or fifth root or seventh root, I don't have a problem with the negative anymore. Okay, so something to consider. Something else to consider, and I'm going to turn the page here, so hopefully we've got everything down. Even roots are kind of weird. We just figured that out on that one. That's when I have I and other types of things. So something you need to think about is this. When you find an even root of an even power, so I haven't done that yet, I don't think. Nope, I haven't. Well, actually I kind of did on number 2, so we might have to go back to that one. And number 1. But when you find an even root of an even power, and, oh, I see, and the result is an odd power. So I haven't had the result be an odd power yet. So if you go back and look, I had an even root, an even power, I ended with an even power. When I did that for number 2, same thing. On number 3, I had an odd power. 4 was fine. So different result here. When I have a result that's an odd power, you must use absolute value so that I make sure it's not negative, because I can't have what we just talked about, a negative under an even root. So my answer, I must use an absolute value symbol so that I ensure that my answer is not negative. Okay, so think about that one more time. So, and it had an even root, so I know that if I have a negative under there, it's a problem, we've got imaginary numbers. So, if I don't have a negative under there, it's an even root, and I have a positive number, but I end up with this odd power. I gotta make sure I keep it positive then, because with an odd power I could have negatives. So, I'm not sure if that completely made sense. Let's try to do an example so you can see what I mean here. So again, our directions are still simplified today. If I have 4th root of t to the 4th. So I hope most of us are just like, well, 4th root of t to the 4th, I'm just going to get t, because t times t times c times c is going to equal t to the 4th. But the point is, this t, I don't want that to be a negative thing. I want to keep it positive, so I got to make sure I've got absolute value bars around that. Because the t was to the 1st power, an odd power. I've got to make sure, well, I want positive here. So let's do another one. Square root of 36 y to the 6th. So square root of 36, we know that it's 6. That's not a problem. But when I do square root of y to the 6th, remember I'm dividing, so I've got y to the 3rd, because there's actually a 2 here, since it's square root. And that's an odd power. So that's a problem. I want to make sure I keep that positive, so I better put that in parentheses. I don't need to put the 6 in parentheses. The 6 is positive already, not a big deal. But I need to keep the odd power, since I had even here and even here. Okay, a couple more to try, just to see if we get the idea. So let's do 4th root of 16, g to the 16th, h to the 24th. Let's do square root of 400, x to the 16th, y to the 10th. Do cube root of 64 times x plus y all raised to the 6th. And let's do 4th root of 16 x minus 3 to the 12th. Okay, so this first one's number 7. First, I've got to be able to do 4th root of 16. So, what times itself? 4 times gives me 16, 2. Then I've got to divide, so g to the 16th, 4th root of that, I'm going to get g to the 4th. Not a problem, because even, and even. And then h, I'm going to do the 24 divided by 4 as well, and I get 6. So those are both even, so I don't have any issues like I did here with the odd power, so I'm just done. I don't need any of those absolute value symbols. But when I look at number 8, let's do number 8, square root. So again, we have an even index, so that I could have these issues where I need an absolute value symbol. Square root of 400 is 20. X to the 16th, if I'm taking the square root of that, I'm going to divide by that too, so I'm going to have x to the 8th. That's not a problem, it's even. Y to the 10th, I'm going to divide by the 2 again. I get y to the 5th. That's a problem. I've got an odd power, so I've got to make sure that I put absolute value bars around that. It's the only one though. I didn't have a problem with the 20, the numbers are fine. I didn't have a problem with this even power, but I have a problem with the odd one. Got to put absolute value bars in there. Okay, so the last couple, same idea. Cube root of 64. What times itself 3 times gives me 64. I think we've already had this one today. It's 4. X plus y to the 6. So I've got this whole thing raised to the 6, so I'm going to keep the whole thing. It's just what's it raised to? Well, I'm going to do 6 divided by 3 is 2. And this one, I didn't even have an even power or an even index. Sorry, I did have an even power. I didn't have an even index, so if I don't have an even index, It doesn't matter. I don't have an even root. This is fine. I don't have to think about absolute value. Now I have an even index for number 10. So I'm taking an even root, so I have to think about things. We already did 4th root of 16 up here. It's 2. I have my x minus 3. 12 divided by 4 is 3. There's that odd power. That's a problem. This needs to be in absolute value bars. The 2 doesn't. Just what has the odd power, which was this whole thing. So hopefully this is kind of making sense. I did a couple extra examples just to make sure. The last thing I want to show you is how you can find these in your calculator, because that'd just be nice, right? So in your calculator, if you want to take a root, we'll just do some of the ones we already did before, and we'll do a couple that are decimals. If I want to take, like, let's say earlier when we had the 5th root of 243, and I don't want to take the time to figure it out. In your calculator, you should see that above the, no, this one's in a different spot, just kidding. Under math, if you look partway down, you've got something there that has this X and then the root symbol. That's the button you want. Now the problem is, well, this one's okay, you can type it in. I was going to say, if it doesn't have a blank there, you'd have to type in the number first. But since I want 5th root of 243, I just put my 5 there, 243 there. I can arrow out if I want to do some multiplying or anything else with it, whatever I want to do, but it's going to give me the answer in the end of 3. So again, where this is at is math, and then 5. Okay, so let's do just a couple more, just decimal ones that aren't even. So if I ask for 4th root of 71, you just have to type it in. And I would have to ask you something like estimate to a certain number of decimals. So again, I'll quit out of that. If I want to get to it, I go math, and then I just go down to 5, or I can hit the number 5. So 4th root of 71 is about 2 point, and then I'd have to tell you, so let's round to 3 decimal places. So 2.903, because I'd have to round that up. So use your approximately symbol here, 2.903. One more just for fun, last one. 5th root of negative 43. So I can do a negative under an odd power, and this is kind of your proof behind that then. So if I go math, and down to 5, 5th root, negative 43, and it's just fine with it. Unlike if you tried to do something else, and I guess I'll show that quick. So this one was negative 2.122 about. Because I don't know, have we ever tried to do square root of a negative number? Something that I can't actually do because it's imaginary? What does the calculator say? It says error, non-real answers. They can't tell you imaginary answers or something like that. Just reads an error. But this kind of proves then, yeah, I can take roots of a negative answer. So anyways, that should be enough to do this. We'll talk about it more when I see you guys again, but do everything that you can. It should be okay, but we'll answer any questions when I get back. Thanks.